Hi all, welcome to Unit 5, Lesson 5. Our topic today is infinite limits. I want you to try the warm-up on your own, so pause the video and so without the calculator, I substituted values from -2 to 2 for x and found my y values, right? We're all good with that. And I also sketched it. And look at this, the red line, that is your vertical asymptote, x equals 0. Again, what's an asymptote? The graph gets very close to it, but will never touch or cross, right? So we are given two questions here to answer. So it says find limit as x approaches 0 from the left. So as x is approaching 0, I'm going to use the highlighter. And I'm going to actually use the thinner one. Okay, so as x is approaching 0 from the left, where is my y values going? It's going what? Down to -infinity. Do we all see that? Right? The more closer I'm getting to 0, the it is approaching -infinity. And similarly, as my x is getting more and more closer to 0 from the right, my y or my f of x is approaching +infinity. Okay, so what are infinite limits? Let's talk about this. Infinity is a very special idea. It's not a concrete number, but a really long, never-ending journey. We all know that, right? In general, we write symbolically limit as x approaches c f of x equals infinity to indicate that the values of f of x tend to become larger and larger, right? If they're increasing, that's when we use that, and a positive infinity. And limit as x approaches f of x equals -infinity to indicate that the values of f of x tend to become smaller and smaller. This does not mean that we are regarding infinity as a number. Be very careful of that. Nor does it mean that the limit exists. It simply expresses the particular way in which the limit does not exist. So copy that and then I'll explain, and it's very self-explanatory. It says limit as x approaches c f of x will be either +infinity or -infinity depending. Then there is a vertical asymptote at x equals c, which we saw in the question above, and I'll just say that. Look here. As it was approaching -infinity from the left and the right, where was our vertical asymptote? At x equals that number, which was 0. Right? So that's what we can conclude, that if it's approaching positive and negative infinity, most likely we have a vertical asymptote there. Can scroll up. Okay, so let's get started with the lesson. Knowing where a particular function has a vertical asymptote, right, we will allow you to quickly evaluate limits at these x values. So for the function r, whose graph is shown, state the following. Limit as x approaches to r of x. So let's look at it. So you're going to check the limit from the left and the right. So I'm going to just trace it from the left. It's going down. As x is approaching 2, my y is approaching -infinity. And from the right also it's approaching -infinity. So I'm going to write -infinity, right? It's going to be -infinity. So the next one is limit as x approaches 5. So let's check from the left and right. I'm going to take a blue. From the left, up, left, look here. It's going up. As I'm approaching 5, it's going up here. I know it's overlapping, it's usually shouldn't, but it's just the highlighter. So it's approaching +infinity. Right? Now, limit as x approaches -3 from the left only. So from the left, I'm going to trace it. Oh, my highlighters. It's approaching what? It's going down, so it's going to be -infinity. And then from the right, it is going to be, if I trace that, oops, if I trace it from the right, it's going up. As x is approaching -3, my y is approaching +infinity, right? So that's basically it. Now it says the equation of the vertical asymptotes. Even if I was given this stuff, I could have read it from there, right? So graphically, do you agree that there are vertical asymptotes here? These are all vertical lines, right? Vertical lines are x equals, so it's going to be x equals -3, x equals 2, and x equals 5. So these are the three places where you have a vertical asymptote. Now, when you're doing it, that was graphically, and now we're going to do these without a calculator. So please don't use the calculator. Okay, so here it says find each of the following limits without a calculator. So basically you need some kind of values to determine it. Either you need a graph or you need, like, you know, something. So I am going to set up a table. And what values do we pick? Since this is very important, what x value is it approaching? Since it's approaching 1, I'm going to take two numbers lower than 1, which would be 0 and -1, and two numbers larger than 1. Two numbers to the right of 1, I meant. So that's what it is. Substitute these values into the calculator. So the first one you'll get 3/4, right? Not the calculator. I said calculator. I'm sorry about that. I meant into the equation. So this is 2/1. You know, at 1, this would be 2. You'll have an error. 2, if I substitute 2, it'll be 0. 2 minus 2 is 0. And 3 would be -1/4. Okay, once you do the table, just watch this one, guys. I'm going to take a different color. So as I'm approaching from the right one and left one, I'm going to see what's happening to my values, whether they're increasing or decreasing. And that will help me determine that what is going on with this question. So as I'm approaching from the left, what's happening to my y values? Are they increasing or decreasing? That's 3/4, that's 2, it's increasing, right? So I'm just going to write, actually, they're going towards infinity. So here from the right, as I'm approaching 1, what's happening to my values? They are also increasing. Since the left and the right are same, so it's going to be positive infinity. So a limit as x approaches 1 of this function will be just infinity. Okay, so now let's try the next one. I'm going to try to do it in a different color, and I'm going to zoom in a little. So again, start with your table. Okay, be careful. This plus means from the right, right? So I'm only going to pick two values that are to the right of my -3. So to the right would be -2 and -1. And this is my xy table. At -3, I know I'm going to have an error, because if I substitute -3 in, I get my denominator of 0. You substitute the others, this would be -2/1, and this would be just -1, right? So now again, check, we're going in this direction. We're going towards -3. So what's happening? As I'm going towards, as x is approaching -3, what's happening to my y values? -1, -2, they are decreasing, right? So this is approaching -infinity. So this would be -infinity, right? So when you don't have a graph and cannot use the calculator, this is how you do these questions. So again, let's set up a table. Let's use a different color. So again, this is 3 from the right. So give me two numbers that are right of 3. They will be 4 and 5. If anyone's confused, think about it. This is a number line, guys. This is 3. What are the numbers on the right of 3? Isn't it 4 and 5? We're working with integers. If I said as x is approaching 3 from the left, then I would have taken 1 and 2. So if anyone is confused about that idea, where we're getting these numbers from or how is it working. So I know I'm approaching 3, and it's an error at this. So substitute in these values. I'm just going to substitute with you. So it'll be 4 minus 3 minus 1 over 4 minus 1 is 1. So which would be 0. Right? This would be 5 minus 3 minus 1 over 5 minus 3, which is 3/2. 3/2, yes. Okay. So now again, the same idea. Check out your limits. You are approaching 3. What's happening to your y values? Are they increasing or they decreasing? They are. This is 3/2, which is 1.50. So they're decreasing. You can even write that. That will give you an idea. Whatever makes you understand this. So this would be -infinity. Finish up the remaining practice problems. Good luck.